Welcome to the Subskills video for Chapter 5. Today, we are going to work on finding the domain and simplifying rational expressions. In addition, we will perform various operations on rational expressions, and we will wrap up with simplifying complex fractions. So for the first example, we are going to find the domain and simplify each expression. For part A, we have x minus 4 in the numerator, and in the denominator, we have the quantity 4 minus x times the quantity 2x plus 1. So let's remember that the domain is the set of x values where our expression is defined. So what we're trying to look for is what would make this expression undefined, and we have to exclude those x values that make this expression undefined. And you may recall that we have, if we get 0 in the denominator, then that expression will be undefined. If 0 is in the numerator, then that just equals 0. That is well defined. That's a number. But 0 in the denominator makes our expression undefined. So essentially, we have to find all the x values where just the denominator, we do not want that to equal 0. So we're going to find those x values that will not give us 0. So essentially, we're just going to solve this as if we're solving equal to 0, but instead of saying those values are the solution, those are the x values that are excluded. So we have this in factored form where we have one quantity times another quantity not equaling 0. So that means that neither quantity may equal 0. So x minus 4 cannot equal 0, and 2x plus 1 cannot equal 0. Because if either of those quantities equaled 0, then the product would also equal 0. So let's go ahead and solve each of these separately. Again, we will solve them as if they were equations. Notice on the first 4 minus x cannot equal 0, I could just go ahead and add x to both sides since I had a negative x, and we just get 4 cannot equal x. On the right, first we will subtract the 1 from both sides. We get 2x cannot be negative 1, and then we will divide by 2. And so we get x cannot equal negative 1/2. So now our domain is all x values such that x cannot equal 4 and x cannot equal negative 1/2. So all other x values are allowed. Next, we also need to simplify this expression. So take a look at x minus 4, or take a look at that original expression. And generally speaking, we can only cancel two different quantities in the numerator and the denominator if, first of all, everything is factored and the factors are identical. And we'll see we have this x minus 4 and this 4 minus x, and those are not identical. However, let's explore that a bit. Because if we have something like, let's explore what happens if we have an a minus b over a b minus a. So let's just explore that. So let's see, let's just do it with real numbers. So how about 10 minus 5 over 5 minus 10? Okay, well, 10 minus 5 is just 5, but 5 minus 10 is negative 5. And then we go ahead and divide those and we get negative 1. Okay, let's play that with that another time. Let's go 3 minus 2, or I'm going to start with 2 minus 3 over 3 minus 2. Let's see what we get there. 2 minus 3 is negative 1. 3 minus 2 is positive 1. we divide those and we get -1. So what we see is when we have an A minus B over a B minus A, those don't cancel out exactly, but they would cancel out and give us a factor of a -1. So when we go to simplify this expression, we can cancel the x minus 4 with the 4 minus x. However, we'll get a factor of -1. And I always put that -1 on top, or I generally do. And so the simplified expression will be a -1 on the top and the 2x plus 1 in the denominator. And notice that the x being 4 is not a problem for the simplified expression. However, the original expression, x cannot equal 4. So the only time these are equal is when x is not 4 or -1/2. So our simplified expression is this right here, the -1 in the numerator and 2x plus 1 in the denominator. And our domain is all x values such that x cannot equal 4 and x cannot equal -1/2. Okay, moving on to the next one. Now we're going to find the domain and simplify. The very first thing we're going to want to do is to factor, because right now, first of all, nothing can simplify right now because we have addition and subtraction. In this case, just subtraction in the numerator and the denominator. So you cannot subtract, you cannot cancel when you have subtraction over division. However, if we factor it, then we will make the two factors will be multiplying, and then we might be able to cancel in that case, because multiplication may cancel over division. So notice we have two trinomials. In the numerator, we have x squared minus 2x minus 15. And since there's no constants in front of the x squared, we could just simply find two numbers that multiply to -15, multiply to c, and add to b, or add to -2. So we think about all of our factors. What multiplies to 15? 1 and 15, no. 3 and 5 might do the trick. So let's try it. 3 and 5. Since they're multiplying to a negative, we'll need one positive, one negative. And we are adding to a negative, so we need more negatives than positives. So that'll be a +3 and a -5. And so, again, since the coefficient in front of x squared is just a 1, we can simply go straight into x plus 3 and x minus 5. Of course, you can always multiply that out to check. Next, we'll do the same for the denominator. So what multiplies to c, or -5, adds to b, -4. Well, there's not many integers that multiply to 5, so it's going to be 1 and 5. And again, we need more negatives than positives. And notice 1 times -5 equals -5, and 1 minus 5, or 1 plus -5, equals -4. So those are the two numbers, and we can go ahead and factor. So in this case, I'll go ahead and simplify first because it's kind of natural to do that. So notice we have two identical factors. We have this x minus 5 on the numerator and an x minus 5 in the denominator. And so those cancel out because when they divide one by the other, you just get 1. And so our simplified expression is simply x plus 3 in the numerator and x plus 1 in the denominator. However, when we go to do the domain, to find the domain, we have to look at the denominator before anything is canceled. So still, we need that whole original denominator to not equal 0. So we'll set that up by x plus 1 times that quantity x minus 5 cannot equal 0, which means again that each factor may not equal 0. So we get x plus 1 cannot equal 0, x minus 5 cannot equal 0, and now let's solve for x. Subtract 1 from both sides to get x cannot equal -1, and we'll add 5 to both sides, and we get x cannot equal 5. So our domain is going to be all x values such that x cannot equal -1 and x may not equal 5. And then let's practice one time where we also put this in interval notation. So essentially, we're just trying to exclude -1 and +5. And so all these other values are allowed. And so we will put that domain, you'll see we have 3 separate intervals. So this first one is -infinity to -1, exclude -1. The middle interval goes from -1 to 5, and that third interval goes from +5 to +infinity. So that's our domain, either in set builder notation or in interval notation. Okay, so now let's go ahead and work on some different operations with our rational expressions. So to start, we're going to be multiplying 2 rational expressions. So let's recall that when we're multiplying 2 fractions, and you could even do something as simple as, 2/3 times 4/5, we just multiply straight across. 2 times 4 is 8, 3 times 5 is 15. Or if we did another one, we could even look at, what if we had 2/3 times 3/4? Well, in this situation, we could multiply straight across first and then simplify. But another option is instead to reduce first. So here, the 3's are identical, and we have a 3 in the numerator and a factor of 3 in the denominator, so we can cancel out. And in addition, we can reduce the 2 and the 4 by 2, and we get 1 and 2. And so we can go straight to 1/2. And this is going to be how that canceling first is how we will generally deal with our multiplying rational expressions. So let's go for it. So first step is we want to try and factor each piece. So here we'll factor that numerator. And notice that we have a trinomial again, where our leading coefficient, or the coefficient in front of x squared, is 1. So it's just what multiplies to c adds to b. So what multiplies to -8 adds to -2, and we play with it. 1 and 8 doesn't work. 2 and 4 might do the trick. +2 and -4. Because the 2 times -4 is -8, and 2 plus -4 is -2. So our numerator will now be factored into x plus 2 and x minus 4. Now our original denominator is just an x minus 4, so we'll just leave that. And the next rational expression, 6, we'll leave alone. And now for 2x plus 4, we notice there's no x squareds, but whenever we go to factor, the first thing we want to look for is our GCF. And notice there's the GCF of 2 and 4 is 2. So we can factor out a 2, and we're left with x plus 2. And notice if you distribute back, you would still get that 2x plus 4. So now let's see, anything in the numerator, or any factor in the numerator, can cancel out with that exact factor in the denominator. So notice we have the x minus 4 in the numerator and in the denominator. We also have an x plus 2 in the numerator and denominator. And then last but not least, we have 6 and 2. And notice 2 is being multiplied by that quantity. So the 6 and the 2 can reduce by 2, and we get 1, or 2 divided by 2 is 1, and 6 divided by 2 is 3. And now we're ready to multiply straight across, and we get 3 over 1, or just 3. So as long as this expression is defined, this will always equal 3 for any value of x, as long as it doesn't make this original expression undefined. Okay, now let's go ahead with adding rational expressions. So just as we have, if we're doing something like 2/3 plus 3/4, and we're trying to add two fractions, we need a common denominator. So first we find the LCD between 3 and 4, and we know, okay, it's 12. And that might take a little more time for some. And then we say, okay, well then we need to multiply top and bottom of 2/3 by something to get it in terms of 12. So we say 3 times what is 12? And since 3 times 4 is 12, we'll multiply top and bottom by 4. And so we find that 2/3 is equivalent to 8/12, that 2 times 4. Same thing for 3/4. Now we're going to multiply top and bottom by 3 and find out that 3/4 is equivalent to 9/12. And now we're ready. And notice the denominator stays the same, but the numerators will add. Okay, so now let's put this into practice with this expression here. So we look at our denominators first. We have x plus 2 and x minus 2. And notice those have nothing in common, even though they look similar. An x plus 2 and an x minus 2 are different. We couldn't cancel those out if one was in the numerator and one was in the denominator. So our LCD will just be the product, x plus 2 times x minus 2. So first, I like to go ahead and just copy down that expression. So here we have, and I'm going to leave a little more room too, x minus 2 over x plus 2, and then x plus 2 over x minus 2. So just as in the fraction example up above, I wanted both of them to have that least common denominator. So essentially, I'm trying to get both of these to have an x minus 2 and an x plus 2 in the denominator. So in order to be able to do that, I have to figure out, well, what's missing here. So I like to put parentheses around the numerators and denominators just to see. And if you look on the fraction on the left, or that rational expression on the left, we already have an x plus 2 in the denominator. So this x plus 2 is already there. We're missing the x minus 2. So now I'll go ahead and multiply top and bottom by x minus 2. And then I can go ahead and multiply those out. So making sure to distribute. So we get x squared minus a 2x minus another 2x plus 4. Now on the right, notice I already have an x minus 2, but I'm missing the x plus 2. So on the right, I will multiply top and bottom by x plus 2. And again, here we'll distribute, so making sure that x multiplies to both and the 2 multiplies to both. So we get x squared plus 2x plus another 2x plus 4. All right, so now we have two expressions and they have the same denominator. So we are ready to rewrite that in terms of one fraction, and the denominator stays the same. So the denominator will stay x minus 2, x plus 2, just as in this example up above. The 12, we had 8/12 and 9/12. We add the numerators, but that denominator stays the same. So feel free, you could simplify right now, or you could just write it all out. We have an x squared minus, I'll simplify as well. I'll simplify the numerators, minus 4x plus 4. And over here, we have an x squared plus 4x plus 4. Now we're ready to go ahead. Again, the denominator will stay the same. But in the numerator, we can combine like terms because right here we just have addition. So we can just do x squared plus another x squared is 2x squared. Negative 4x plus 4x, those cancel out, but we get 4 plus 4 is 8. So in the numerator, we get 2x squared plus 8. Now, it's always good to check that you can't simplify any further, especially when we're doing adding and subtracting. So what we'll go ahead and do is we'll try and factor that numerator. So 2x squared plus 8 does have a GCF of 2, and we get x squared plus 4. And then denominator stays the same. And notice that we have a factor of 2 in the numerator, but that cannot cancel with, it's not an identical factor to any of those factors in the denominator because it's an x minus 2 or an x plus 2. And x squared plus 4 cannot be factored anymore over the real numbers. If it was x squared minus 4, that would be different. And we are welcome to leave our answer in either of these. Both of those would be acceptable answers. Similarly, you can multiply it out. So you could also have 2x squared plus 8 in the numerator. And if you multiply out the x minus 2x plus 2, we'll get an x squared. The 2x and the negative 2x cancel, and then we get minus 4. So all three of these expressions are acceptable answers. Normally, we would want, when you simplify an expression, you would want it in that everything multiplied out. However, for rational expressions, almost everything we do with them involves factoring. So it is totally acceptable to leave your answer in factored form if it's a rational expression. Okay, next, let's do some subtracting, and then we'll do division, and then we'll get into subtraction. So for part C, we have x squared minus 9x plus 8 in the numerator and x minus 4 in the denominator. And then we're dividing it by the expression 3x minus 3, all divided by the expression x squared minus 16. So the first thing, there's kind of two steps to remember. First is we want to go ahead and remind ourselves that when we divide fractions, the first fraction will stay the same, and the second fraction, we can flip it or find the reciprocal, and it turns into multiplication. And so then all of our same rules apply for multiplication. We'll factor and simplify and everything. So first step, we'll go ahead and just flip that second rational expression. So the first rational expression will just stay the same, and the second rational expression will flip. So the x squared minus 16 will be over 3x minus 3, and instead of the division, now it's multiplication. So we are ready to factor each of the expressions. On the top left, we see it's a trinomial because there are 3 terms, and there's no coefficient other than 1 in front of the x squared. So we're simply looking for 2 numbers that multiply to c and add to b. So what multiplies to 8 and adds to negative 9. So 1 and 8 multiply to 8, but they don't add to -9. So if they're both negative -1 and -8, then when we multiply them, we get a +8, but when we add them, we get a -9. So the top left will factor into x minus 1 times x minus 8. The bottom left is not factorable. And the top right, now, there is no GCF for x squared and 16. So we figure out, okay, how can we factor something with only 2 terms if there's no GCF? One common way is if we have a difference of squares, or a squared minus b squared can be factored into a plus b times an a minus b. So since both x squared and 16 are perfect squares of x and 4, then we can factor x squared minus 16 into x plus 4 times x minus 4. And lastly, on the bottom right, 3x minus 3, there is a GCF of 3. So we factor out the 3 and we're left with an x minus 1. So now we look, are there any identical factors in the numerator and denominator? And we have an x minus 1 in the numerator and 1 in the denominator, so those could cancel out. And we have an x minus 4. And so our final answer is, we'll just multiply straight across and get that x minus 8 times an x plus 4. And in the denominator, we only have a 3. So this is an acceptable answer. Because it's a rational expression, you can leave it in that factored form, or you can multiply it out, and after simplifying, we will get x squared minus 4x minus 32 all over 3. So either of these answers are acceptable. And for D, we are now going to subtract rational expressions. So the first thing we want to do is go ahead and rewrite that denominator on the left in factored form. So again, what multiplies to C adds to B. So what multiplies to -12 and adds to 4, because it's a trinomial. And 1 and 12 does not work, but 2 and 6 may work. But since it's multiplying to a negative, we'll need 1 positive and 1 negative. And since it's adding to a positive, we will need more positives than negatives. So -2 times 6 gives us -12, and -2 plus 6 gives us +4. So that denominator on the left will factor into x minus 2 and x plus 6. I will copy down on the right. Now that I see we have similar factors, we have this x minus 2 in the denominator on the left and a 2 minus x in the denominator on the right. So it would be nice if we could make those be the same, at least that factor. If we could change the 2 minus x into an x minus 2. So one way we can do this is we could go ahead and, actually there's a lot of ways you could do this. One way you could do it is you can multiply top and bottom by a -1. Okay, if we multiply the top and bottom of that fraction by -1, then all of a sudden we get a negative x up top, and now we have a -2 and a positive x, so we could rewrite that as x minus 2. And again, because when you distribute this -1, we get a -2 and a positive x. So we could reorder it as x minus 2. I'll copy down the rational expression on the left. Now, we're ready to find the common denominator. So since they both have an x minus 2, we will need an x minus 2, but we'll also need an x plus 6 as a factor as well. So you see on the left, we already have an x minus 2 times an x plus 6, but on the right, we only have the x minus 2. So we're really trying to get both of them to be the x minus 2, x plus 6, and over on the right, we're trying to get an x minus 2 and an x plus 6. That's what our goal is. And then one other thing you notice is we have this minus a negative. These two right here will turn into a plus x. Okay, so now in order to get this x plus 6 in the denominator, we have to multiply both the top and the bottom by that x plus 6. So we're going to end up with that x times that quantity, x plus 6. So now we're ready. We need all one denominator, and that denominator will stay the same. So x minus 2, x plus 6 is that common denominator. And then we just simplify the numerator, x plus 8. And then you could skip this step and just distribute right here, or I'll go ahead and distribute it now. So the x distributes to both the x times x is x squared, and to the 6. X times 6 is 6x. Copying down that numerator or the denominator. And last but not least, we'll go ahead and combine like terms in that numerator. We got x squared plus, we have 1x plus 6x gives us 7x plus 8, all over x minus 2, x plus 6. And we could try and factor the numerator just to see if we could simplify any further. But if we look for what multiplies to 8 and adds to 7, you could try 8 and 1, but those will add to 9, or they could both be negative, but those would add to negative 9. So the numerator is not factorable, so we could leave it as such, or we could multiply out the denominator. Either way would be fine. Because we have the luxury of time, I'm going to show you both methods here. So we're going to do, first we'll do the clearing using the LCD. And I like this method because it's common to be used a lot in pre-calculus and in calculus. However, I find a lot of other students like more simplifying the numerator, simplifying the denominator, and making it more similar to dividing rational expressions like we just did. So I will first show the method of clearing out using the LCD. And then then I'll do these same two examples and show how it can be done using just more arithmetic. So first step, we need to look at all, so this is a complex rational expression because we have fractions within fractions, or rational expressions in the numerator and rational expressions in the denominator. So the first thing we need to do is find the LCD. And what I'm talking about with the LCD is the inner denominators. So if, you know, those denominators of the smaller fractions. So we see that we need an x and we need a y. So xy will actually be the LCD for all four of those fractions. So what we're going to do is we're going to multiply the top and bottom of this big fraction here. We're going to multiply by the LCD. So I'll multiply by xy, top and bottom. And so notice, because I'm multiplying over addition or subtraction, I need to distribute. So let's go ahead. First, I'll just copy down the expression. And then I'm going to multiply both of them by an xy over 1 if you prefer. You can always do it over 1. And then I'll do the same on the denominator. So I have x over y minus y over x, and then I'm multiplying each term by x over y, or that LCD. xy is the LCD. Okay, so now essentially what we need to do is we're going to simplify each of these four expressions individually. So first one, top left. Notice here in the numerator is a y, and in the denominator is a y. So we could go ahead and cancel the y's out, and then we're just left with x times x, or we get an x squared. Now on the top right, now we have an x in the numerator and an x in the denominator. And notice everything's multiplying and dividing in this expression right here. We don't have any adding or subtracting inside that circle. So here, the x can cancel with in the numerator and denominator, and we're just left with a y times y. So we get plus y squared. Next, we'll do the bottom left. Again, notice the y's will cancel, and we get an x squared. And the bottom right, the x's will cancel, and we'll get y times y, or minus y squared. And since the numerator cannot be factored because it's an x squared plus a y squared, it's a sum of squares, which is not factorable over the reals, we are actually done. Okay, now I'm going to go ahead and do this same exact problem, but doing it a different way, where we'll kind of do more similar to those operations we did up above in that previous example, in example 2. So first thing, I'm just going to do this addition in the numerator. And so I'll need a common denominator. And similarly, I will do the subtraction in the denominator. Again, I'll need a common denominator. So in both of these cases here, for the top, the LCD is XY. And in the denominator, the LCD is also XY. So I need to let's just focus on the top here. So here in those two expressions, I need both denominators to be XY. So here I'm trying to get XY in both denominators up top. So on the top left, I already have a y, but I need an x. So I multiply top and bottom by x. And on the bottom, I get the xy like I wanted, but on the top, I get x times x, or x squared. Top right, I'm trying to get xy. I already have the x, so now I'll multiply top and bottom by y. So I got the xy in the denominator, and the numerator is y times y, or y squared. Let's do the same thing in the denominator. So again, the LCD is still XY. So I want XY in both denominators. And on the left, I need to multiply top and bottom by X. And I had copied the minus wrong. I changed it to a plus, but I just fixed it. Okay. And on the right, I have an X, but I'm missing the Y. So I'll multiply top and bottom by Y, and we get the Y squared. So right now, technically speaking, nothing can cancel. However, once I get it into one fraction in the numerator, so my denominators are the same, so I keep the denominator XY, and my numerators I add. They are not like terms, so I just get x squared plus y squared in the numerator. For the bottom, now looking here, again, the denominators are identical. So I will keep those denominators the same. Now I can subtract the numerators, but I want to make sure they're not like terms, so I just get x squared minus a y squared. Okay. So if you feel comfortable at this stage, because we have one fraction over another fraction, and the denominators of both of those fractions can cancel out. So this is allowed. However, if you're not comfortable with that, let's go ahead and go one step further, and we're going to change this into division. We're going to treat this big division bar or fraction bar, division bar, we're going to treat it as division. So the top now will stay the same. And then we will flip the bottom fraction and multiply. So now we can see the xy's will in fact cancel, because those are both identical factors there. And then in the numerator, we get x squared plus y squared. In the denominator, x squared minus y squared. And notice we got the same thing either way. Okay, when we did it up above, we just found the LCD of all of those fractions and just multiplied to clear those denominators right away. On the bottom, instead, we kind of did more order of operations where we just added the top, subtracted the bottom, and then again, notice if we just would have canceled the xy's here, we'd get, you could skip this step. So you could, it's optional to go straight down here. That is allowed. Okay. All right. So if you have a strong preference one way or the other, you're welcome to just focus on one method here, or, you know, get acquainted with both, and then, you know, how you know both methods moving forward. So first I'm going to do the method of just clearing the fractions. So I need to find the common denominator for all four of those fractions. And in this case, we need an x plus 2 and we need an x minus 2. Okay. Oops. So the first thing we need, oh, hang on, let me just copy this down. Because that next step is going to require me to copy it. Okay. Oops, that looks a little messy, too close. So the first thing we're going to do, if we're using this method, is we're going to multiply the top and the bottom by the LCD. So we're going to multiply it by x plus 2 and x minus 2. And really, that's like over 1. Okay, each of those. So what that ends up doing is we have to distribute that whole quantity here to both of the fractions. So what that ends up looking like is we multiply this first fraction on the top left by x plus 2, x minus 2 over 1, and that top fraction on the right, x plus 2, x minus 2. And a lot of times I'll skip this step right here and just go straight here, or just write that top one and figure out what cancels. So a lot of times once you get practice, you'll only write out one of these two steps shown. Okay, so now I'm ready to cancel because these are factored, and here those denominators are just unique expressions that are identical. So look at the x plus 2 on the top left, that x plus 2 in the numerator and denominator will cancel. And we're just left with an x times an x minus 2. On the top right, the x minus 2's cancel, and we're just left with the 4 times x plus 2. In the denominator, on the bottom left, the x minus 2's cancel, And we're left with a 2 times an x plus 2. And on the bottom right, the x plus 2's cancel, and we're left with that negative x times x minus 2. So right now, even though this looks like there's factored parts, the top is not factored because of the subtraction, and the bottom is not factored because, or the top is not factored because of the addition. The bottom is not factored because of that subtraction in there. So first we will multiply everything out. So here, distribute the x squared minus 2x plus 4x plus 8 after I distribute the 4. In the denominator, 2x plus 4. And then make sure we're distributing the negative x. So negative x squared, and then we get a plus 2x because we're multiplying this negative x by that negative 2. And a negative times a negative is a positive. All right, let's go ahead and combine like terms. On top, x squared plus 2x plus 8. In the denominator, negative x squared plus 4x plus 4. So we have to be careful because we want to make sure we factor if we can. So we might see, okay, well, what multiplies to 8 and adds to 2? Oh, maybe 2 and 4. But we notice that they either both, because it's multiplying to a positive 8, then we they would have to both be positive or both be negative, and either way they will not add to 2. So technically speaking, we're done as soon as we see that the numerator does not factor. If I were to factor the denominator, the first step I would do is factor out the negative, because it's much easier, in my opinion, to factor it if there's no negative in front of your x squared. And then here, again, you could see, you can try it out, but this is also not factorable because what multiplies to negative 4 and adds to negative 4, 2 and 2 might work, but again, one has to be positive, one negative. So that does not end up working out. So that is our final answer, x squared plus 2x plus 8 in the denominator, or in the numerator, and negative x squared plus 4x plus 4 in the denominator. Okay, and then one last time, we'll go ahead and do the same problem, just finding common denominators. So we'll do that addition up top, do the subtraction on the bottom. So here, my LCD is in fact x plus 2, x minus 2, again, for the numerator and the denominator. It's not always that way, but it is common. Now, so for that, for the top, I'm trying to get, my pen is bugging out again. Weird. Okay, let's try a different one. There we go. Okay. All right, here we go. So I'm trying to get in the numerator, so first I'm just going to focus just up top here. So I'm trying to get an x plus 2, x minus 2 in both of those denominators. So on the top left here, you see I already have an x plus 2. So now I will go ahead and multiply top and bottom by x minus 2. Oops, right there. There we go. My red doesn't want to work here. So on the top, I get that x minus 2. And on the top right, I already have an x minus 2. So now I'll multiply top and bottom by an x plus 2. So I got that 4x plus 2. Now, bottom left, or looking at the two fractions in the denominator. So now I'm just focused down here. Now, again, the LCD is x plus 2x minus 2. So I'm trying again to get everything in with that denominator, x plus 2, x minus 2. So if you look at the bottom left, I already have an x minus 2. So now I need to multiply top and bottom by an x plus 2. So that gives me that 2x plus 2. On the bottom right, I already have an x plus 2. So now I need an x minus 2. So x minus 2. All right. So now I'm ready. In the numerator, they have the same denominator, so that denominator stays the same, x plus 2, x minus 2. And then I just get, I can put those numerators, I'll add them. I'll simplify in a moment. Same thing in the denominator, the bottom big denominator, I have that common denominator, x plus 2, x minus 2. And then I have 2x plus 2 minus x minus 2. And so in this case, I will just go ahead. Now that we have one fraction in the, we have one fraction in the numerator and one fraction in the denominator, here, I'll go ahead and do that trick where the denominators cancel. And it's because we have one fraction on top here. We have this one fraction on top over this one fraction on the bottom, and they have identical denominators, so they cancel out. And so now we're ready to simplify. So in the numerator, we have that x squared. Oops. X squared minus 2x. Then we'll distribute the 4 to get 4x plus 8. In the denominator, we have that 2x plus 4. And then again, careful with distributing that negative x. So we get negative x squared, and then a negative x times a negative 2 is a positive 2x. We will simplify like terms. X squared plus 2x plus 8 all over negative x squared plus 4x plus 4. And as we played with it up above, neither of those expressions are factorable, so that is our final answer. And again, because we have adding and subtracting in the numerator and in the denominator without it being factored, we cannot cancel any of those terms. All right. So that does it. And these skills right here of dealing with rational expressions and these complex expressions are really important for simplifying trigonometric identities and for verifying that the trigonometric identities are true. And that's all for now.